Okay, this is the P4 paper from October 2023. It's question number 3, and this is an integration by parts and an integration by substitution question. 5 marks and 7 marks for each of these two parts, so quite a bit of work to do for each one. Let's have a look at them. First one says we've got, okay, so part 1, I've got the integral between 4 and 0 of x squared e to the 2x dx. So I hope that some of you are at the stage where you should be able to look at this and say, I know exactly what I'm going to do. When I go through my integration by parts, I will end up with integration of x e to the 2x dx after my first run through, and then I'll need to integrate this by parts to end up with the integral of e to the 2x dx, and then I'll be able to do it. So I know what I'm going to need to do before I get started. Be really careful about the way that I set my work out, but I set them out the same all the time for these integration by parts. So I'm going to choose u to be equal to x squared. That's because when I differentiate u, I get a simpler function, x squared going down to 2x, and yet my dv by dx, I'm choosing that to be e to the 2x, and when I integrate that then, it doesn't get any more complicated. Yeah, there's half in there, but the type of function isn't any more complicated. So my rule for integration by parts is that the integral of u, dv by dx is equal to uv minus the integral of v du dx. I write that down every single time because it means that that formula gets in my head. The method being applied in the same way makes it a lot easier as well. uv is those two, and then v du dx is those two, so I shouldn't really make any mistakes when I'm subbing in here. So uv is x squared over 2 minus x squared over 2 multiplied by e to the 2x minus the integral of the bottom two, so 2x half e to the 2x dx, or in other words, x squared over 2 e to the 2x, and then that's just the integral of x e to the 2x dx. So I knew we'd get something similar to that for that first part. I'm now going to integrate that bit by parts. So integrating x e to the 2x dx, well, again, I'm going to do exactly the same thing. So u equals x this time, du by dx is equal to 1. Should get to be quite quick at this process if you do lots and lots of practice of them. dv by dx is e to the 2x, so v is going to be a half e to the 2x again. So same formula, u dv dx, the integral of that is equal to uv minus integral of v du. So that's going to give me uv, which again is those two, minus du by dxv, which is those two. So that's going to give me x over 2 e to the 2x minus the integral of, and now it's just half e to the 2x dx. And I can actually tidy it up and finish that off then. So that's x over 2 e to the x minus a quarter e to the 2x, and then the reason I was slowing down there was just to think about how I'm going to say this to you then. So this part here is that bit there. So it's this minus all of this here. Just be careful when we do that in terms of my final answer then. So we're now saying that the integral of x squared e to the 2x dx is actually equal to, and it's x squared over 2 e to the 2x, and then it's minus the x over 2 e to the I've lost a 2x there somewhere, sorry. That's 2x there and 2x there. Yeah, everywhere else it's okay, right. X squared over 2 e to the 2x minus the x over 2 e to the 2x, and then plus a quarter e to the 2x. Now, our question was integrating it between 4 and 0 there, So I'm going to stick 4 and 0 into those two bits there. So just take your time over this, say 5 marks, you've got a reasonable amount of time to do it. So just enough so that I'll go over the top, I think, with it. 4 squared over 2, e to the 8 minus 4 over 2, e to the 8 plus a quarter, e to the 8. Oops, excuse me, minus, but just be careful this one. It's not 0, 0 and 0. Yeah, the first one's 0, the second one's 0, but the third one is a quarter, e to the 0, which is 1, isn't it? E to the 0 is 1. So we are going to get a constant value there. Tidying that all up, we've got 25 e to the 8 over 4 minus a quarter, or rather, we will write that as 25 e to the 8 minus 1 all over 4 as my final answer there. And it just said giving your answer in its simplest form, so exact value. Yeah, we don't need to do any more than that. Okay, let's have a look at part 2. So lots of concentration needed on this question. Part 2 says use integration by substitution, and then it doesn't tell me what the substitution is. Okay, so I need to look at this function, and realistically, the simplest thing I can think to do is make u equal 2x minus 1. If I do that, then I'm going to have 1 over u squared there. I know I can get 2x to match up to 4x there. The dx part's not complicated, and even the limits that I'm going to change are not too bad. So that's the substitution I'm going to make. Let's actually just go ahead and do it, and then you'll see all the difficulties that ensue. So part 2 said the integral between 21 over 2 and 0 of 4x over 2x minus 1 squared dx. And as I said, not a problem this time, but normally if I'm doing a substitution, that's the thing I worry about the most. Certainly if it was a trig substitution, then always get that dx first and then see whatever else comes out of it. But this one, no real issues. I've got to substitute that, I've got to substitute that, I've got to substitute that, and obviously I've got to substitute the two limits. Let's just jump in and do all of that. So we start by saying my substitution is u is 2x minus 1. So I'm always going to do my dx first. Du by dx is equal to 2. So in other words, dx is du over 2. Now I'm going to tick this, I'll get rid of it later, but yeah, got that bit done. I also need to get my 2x minus 1 squared. Well, I've got that bit done, that's just u. So it's the 4x that I need, but again, because of the substitution I'm doing here, this is really, really simple. If u equals 2x minus 1, then 2u is 4x minus 2. Just double everything. So 4x is 2u plus 2. So now the only things I've got to find are my limits up there. I tend to do these over here just so the examiner can see nice and clearly what I'm actually doing. So for my limits, if x is equal to 21 over 2, u is 2 lots of 21 over 2 minus 1. Sorry, that is a 3 there. I was copying the first part when I wasn't focusing there. So that gives me equals 20. And this is where I realised it, that it's x equals 3 here. So u is 2u minus 1, 2 lots of 3 minus 1 there. So that works out to be equal to 5. So now I can go ahead and build up my integral. So my integral this time is going to be between 20 and 5. And then the 4x is 2u plus 2. The 2x minus 1 all squared is u squared, and the dx is du all over 2. Let's just go and get rid of those ticks and confuse the examiner. Okay, and then this should be something relatively straightforward to do here, shouldn't it? So tidying all this up, this is the integral between 20 and 5 of the 2's will cancel. So I get u plus 1 over u squared and u plus 1 over u squared. Well, let's do that. U plus 1 over u squared du, which is the same as the integral. Again, as many stages as you want to do with this, as long as we're getting the right answer. That's 1 over u plus 1 over u squared, isn't it? 1 over u squared du, which in other words is u to the minus 1 plus u to the minus 2 du. Okay, so the integral, 20 and 5, the integral of 1 over u is log u, and the integral of u to the minus 2, add 1 onto the power, divide by the new power, comes out to be that. So we've got that between 20 and 5. Let's just go back and see what they asked for it to look like in the format of a plus log b. So they can be a bit sneaky with this. Let's just take our time, make sure we don't do anything silly here. So this is going to be log 20 minus 1 over 20 minus log 5 minus 1 over 5. No, there's no particularly complicated parts to that. Log 20 minus log 5, using our log rules, log of a minus log b is log of 20 over 5, isn't it? So that's log 4, and then minus 20 plus a fifth works out to be plus 3/20. So yeah, I've got that in the format they wanted it there. 5 marks and 7 marks. Hopefully all of that makes sense to you.